Alright, we have arrived at the last section of our problem-solving chapter. Here is an example of results for the cable company that you were supposed to work on when you finished 3.3. So we had voice of the customer saying I want continuous service. CTQs could be number of disruption calls received per day or number of disruption calls resolved per day. Customer says I want timely resolution of service calls. CTQ could be time to restore the service in hour. And then PCIs could be time to answer a service call in minutes or cycle time in minutes from call to service resumption. If you want to take a look at those in more detail, you can print out the lecture notes and take a peek at that. Alright. Ishikawa talked about 7 tools of quality. So those quality tools are the flowchart, control chart, check sheet, histogram, period diagram, cause and effect diagram, and scatter diagram. And Ishikawa said every person in an organization should know how to use those tools, so they have an easy way to have a conversation about quality or problems that occur. He said from the plant manager through the purchasing person, through the quality person, through the maintenance person, operators on the floor, everybody should know all 7 tools. Now we will cover several tools in this class and the rest will be covered in the Six Sigma methodology class. I want to just show briefly what those tools are. You see in the top left corner an example of a flow chart which just kind of gives you the steps involved in a process. On the top right you see a control chart that you can use to monitor processes, see how stable and predictable they are. On the bottom left you see an example of a check sheet used for data collection. On the bottom right you see an example of a histogram, which is just a bar chart that shows frequencies. On the top left you see an example of a Pareto chart where you can see how many % of your problems can be solved if you focus on a certain number of defects. The top right gives you a scattergram. It's used to see whether there is a relationship between 2 variables, and then the bottom you see a cause and effect diagram that you can use to brainstorm on problems. Each tool is explained in a little more detail in your books. I would like you to read about them, and then later on in the semester we'll talk in greater detail about some of those tools. Want to talk about flowcharting a little bit. In the book it talks about different symbols for flowcharts. You see a rectangle for an activity, a diamond if you have to make a decision. You see a circle if there's an inspection point, then you see the symbol for delay, transportation and storage. Here's an example of a flow chart. You can see the steps of the process are connected with arrows, directional arrows. I want to talk in particular about a certain type of a flow chart. But before I do that, in general, flowcharts define process steps. You do it by observing the process. Then you sort the steps into the order of their occurrence in the process. So you could define the steps by just writing them down on post-it notes within your team, and then you sort those steps into the order of their occurrence. You place the steps in appropriate flowchart symbols, you create your chart, and then you evaluate your chart for completion. Those are general guidelines for making a flowchart. I want to talk about a high-level flowchart or a high-level process map, because that's the one you would use typically when you first get started on a project. You use it so you can get everybody on the team on the same page. Now, a high-level process map is a document that links customer needs, process controls and supplier deliveries so everybody will understand how the process is currently done. It's very important that you only focus on the major steps. You don't get bogged down in great detail, so just the major steps. Here's some answers, some questions the process map will answer. Number 1, what's the current best known way to carry out the process? What are the process inputs? What are the process outputs? What's important to the customers? Yes, we put CTQs on a high-level process map. And how do we control what's important to the customer? So we put process control items on the high-level process map. Here's an example of a high-level process map. We have the process steps involved in molding, coding and assembling a part that's then shipped to the customer. So first we mold the part, then we cool it on a conveyor belt, then we degate and package it, we code it, and we assemble and ship it. We also put inputs on a process map, which are those raw materials. For example, acrylic is used in the injection molding process, bubble packs are used in the packaging process, and then a chemical D65X is used in the coating process. Output is the lens assembly. Outputs also go on the process map. Then come the CTQs. Those are the things that are important to the customer. So CTQ diameter is something important to the customer. Since it's affected in the injection molding step, that's where we're going to put it. The coating thickness is also something that's important to the customer. It takes place in the coating step, so that's where we are going to put it. We could also add process control items, for example, injection temperature, mold temperature, injection pressure. We could add that in the respective steps where they are affected in. Here is the procedure for developing a flowchart. I let you read that on your own. You have that in your lecture notes. I want to do one with you on an easy example that everybody should be able to relate to. Let's do a high-level flowchart on doing the laundry. So we're going to start out by putting the high-level process steps down. Sort would be my first step, then wash, then dry. For wash, for example, am I going to put down select water temperature, select cycle time, dump in the detergent? No, I'm not going to do that. I'm just going to focus on the high-level steps, the bird's eye view. So we have sort, wash, dry. Then we have to make a decision, are we going to hang or fold? If we fold, we go to the step fold, and then we store. If we hang, we're going to hang and then store. Now those are my high-level steps. What's missing now is the input, so let's add the inputs into the process. Dirty clothes, they go in the sorting step. Detergent and water go in the wash. Dryer sheets go into dry. We need some hangers in the hang step. And then what's missing is the output, clean clothes. Now we start working with this chart. We're going to add CTQs. To add the CTQs, I could do a CTQ tree diagram. So a customer says, I want clothes that are clean and haven't changed size on me. So cleanliness and shrinkage could be my CTQ. And then PCIs are those things that affect the CTQ. So for cleanliness, it could be amount of detergent, water temperature, agitation time. For shrinkage, it could be dryer temperature, dryer time, water temperature. So let's add those things to our process map. We have our process map right here. Let's add some CTQs. Shrinkage is affected in the step wash. Therefore, I add it in the washing step. Shrinkage also probably is affected in the drying step, so I add it underneath drying. And then I'm going to add my PCIs. Water temperature probably affects shrinkage in the washing step, so there it goes. Dryer temperature and dryer time affect the shrinkage, so I add that under the drying step. So we have created a process map with the steps, with the inputs, with the outputs, with the CTQs and the PCIs. Let's do an exercise. Dry raw ingredients are mixed. The mixed dry goods are transferred to the dough mixer where fat and water is added. After mixing the dough is molded into dog biscuit shapes. Then the biscuits are baked. After baking, some biscuits are coated and then dried, others are dried immediately. Next, the biscuits are packaged and shipped to the customer. The following measures are important to customers: biscuit breakage, dryness of biscuits. They could mold, like, nasty stuff. They could build up nasty stuff, mold, and weight as specified on the box are all things that are important to the customer. So I'd like you to stop this presentation now. So hit the stop button and make yourself a process map, and then start it again to see how you did and compare to the one I'm going to show you. So stop now. This is what the process map looks like that was done at the company that actually made dog biscuits. You can see all the major steps. They're very similar to what you should have. And then you can see on the bottom right corner under the box that says customer were a number of critical to quality characteristics, a number of CTQs. Now in any type of food processing, if it's for animal or people, there's always a lot of things that have to be checked. So you can see a lot of CTQs, and they have numbers in front of them. Because the process map would have been too cluttered, we decided to code the CTQs with numbers and then put those numbers in the respective steps where they are influenced by. And then the process control items itself went straight into the process map. So for example, in dough mixing, in the dough mixing step, you can see the process control items: water weight, visual check, mixing time, water temperature, add SMB, fat addition, and pre-op check. And then whatever is in parentheses behind them are the CTQs that are affected by that particular PCI.